everybody. Do you guys know how old the Earth is? Can someone tell me? Bradley?
400 billion years old.
4.6.
You think 4.6? Anybody got something different? 6,000 years old? Alright, what's your reasoning behind that?
Oh, my mother told me that.
Oh, okay. What?
2014 years old.
Oh. What's your reasoning behind that?
2014.
Alright, and why do you think 4.6?
Because that's when that's the oldest fossils they've ever found.
Alright, Bradley, yours was similar to April's. Did you have the same reasoning or different? Your reasoning behind your number?
This is a big number.
Oh, you going for it? Alright, well, do you guys know how scientists actually figure out dirt? Think dirt? What do you think?
Radioactive dating.
That is one definite way. And actually, the theory says that the Earth is about 4.55 billion years old. So, April, you were pretty close.
I was in that science class.
Good job.
So what we're going to be doing today is actually simulating what Eric was just talking about, the radioactive decay. Everybody is going to get into groups of 3, and then in those groups of 3, everyone's going to have, like, each group's going to have one worksheet to work on as a team. You guys are going to get jobs. You guys are to assign yourself those jobs, and if you don't, then we'll take care of that for you. Here are the jobs, and you write your name by them, so there's no forgetting. So basically, how we're going to simulate this, the directions are here if you're forget in the middle of it or something. But what we're going to do is we're going to open the box. The penny counter, whoever that may be, is going to flip all these pennies over to be heads up in the box. And put the lid closed. The penny shaker is going to shake it twice, up and down. Then you're going to open it. The penny counter is going to take all the heads or the tails up, out into a cup, and count them as you're counting them out. And then the data recorder is going to record those numbers. So it's not that hard. You guys can do this in small groups. Yeah.
Why do they often do the same facing out?
Facing out, because what the pennies represent are radioactive atoms. And when you're doing radioactive decay, in the very beginning, you have all the same atoms. And then the tails up are the daughter elements, what that have decayed, so obviously they're going to be different. So you got to be able to distinguish that difference. So you start out with 1 to begin with.
Smart.
All right. Yeah, go ahead. All right, 1, 2, 3, you guys are grouped. 1, 2, 3, you guys are grouped. Will you go back with Paige and Tommy?
Who wants to do the penny counter?
I'll shake.
I guess you guys
And you guys will be a group of 4. You can take turns writing data. Take your daughter to take around and go.
What if I wanted to please?
You guys are going to do 10 shakes. You're going to do it, record it, and then go back and shake it some more 10 times to make 10 decays. I'm doing it like, yeah.
Not when you're a student.
So she said
But you missed.
Hey, write you up. Throwing stuff.
You should wear that to teachers.
I should.
Yeah, like they would
That would be
listen to you.
intimidating.
I bet.
Probably.
You can take it around a little bit if they don't like it.
Likewise.
I'll do it.
Are you trying to take it?
that radioactivity too.
Yes. You ready?
Last time I did this on the
Do it twice. Usually they don't flip enough.
Kelsey shakes it in Oh, you're supposed to But to put it in the facility. Well, this would be the number 30.
I used to be on Sesame Street.
I don't think so because there hasn't been anything. Like you start out with videos, that one would be like after your first day.
We needed to count.
Yeah.
12
That is what I do.
38.
Do you order like 20 different numbers?
That's a good thing to know. So you 13 is good how to know.
Like, you can do different numbers. So I think we're gonna fill up some more. 0 to 8, 50, 50, take it out.
Yeah, it's like, number of things, so like,
See, no, that's just like numbers. Like, I assume that one motion with a shake.
I assume that it's only like counting.
Yeah. Yeah.
But,
Yeah, so it should be like 1, 2, 3, 4. Because it's more like an hour of eight.
ours is
Really?
We can get together this weekend.
Are you guys done?
Yes, ma'am.
Alright, so they can be better than they're both
These two groups can work together on this sheet and answer these, compare the two results.
like after this, we're supposed to like match it up.
Oh, okay.
Yeah, you're going to.
Take
But,
it.
That is not true. How many?
you know, we did the rats. Is it that matter
That high.
Because some of them
Yeah, I guess we'll just like,
You guys are close enough, or you can
yeah.
just finish.
Alright, so you guys
So,
are gonna turn
alright,
around
so
and work with them.
this group, you guys are gonna work together on this sheet
should
and
we already graphed this?
like compare your.
It's good. Just grab one.
Okay. As long as you have two, that's what
Here you go, Ronald.
What job you
Does Brandon know what you're writing? Is he contributing?
Do it like, one,
Groups at the top.
Yeah,
You're kidding me.
making sure.
This is ridiculous.
Yeah.
You're good?
I've been talking this whole time.
Another thing
No,
is.
I just said, hey, what did y'all get? And I get silence.
I'm sorry.
Tom is there. Yes, there's other people in the group. There's no leader.
I didn't even hear you say it.
So you're saying. But yeah.
Camera, I'll watch the video. I'll hear the camera. It's ridiculous.
We don't understand everything.
Well, go ahead and just graph it now. You guys are ahead of them a little bit, and then you can
What do
compare.
you need? What are your questions?
Just compare. It's like.
Half-life, what does that mean? What about heads, what about tails, what about, is it,
It says in
make
there.
it means we're cutting it in half.
Almost every time.
Where's the definition?
Did you read?
Yeah, we lost
Right?
30. Oh, we lost 15, so we done with you.
I was a shaker, I didn't even see that.
It shows you
Just got it now?
Yeah,
Ready to go? Alright.
Oh, our names are Jimmy, Keith.
Alright, so who's decayed faster?
Yeah.
But we didn't go all the way to zero, we just went down to one.
Yeah. Okay.
Even though it's just reading it, it's still just reading.
Yeah, that way it's easier. We need to make sure. I know.
So we won?
Ours went down faster
No,
at the
there's-
How
beginning.
many do you have at yours?
These are some thinking ways.
Yeah, there's no faster at the beginning.
If you guys feel me to say. Yeah. And then you're gonna move on to.
Excuse me, well, we started off slower, but then we still
All right, why don't you go ahead and put the pennies back in the box? Now you can get back to back.
That could be a word too.
All right. They're good.
Alright, so if everybody can go back to where you were started out sitting. Alright, so when you guys were doing that sheet, it asked you which group's slope was faster, like which one decayed faster. How did you pick which one? Like, can someone tell me why you picked? Like, your arm?
Well, we picked ours because we had less attempts to get to zero than they did.
Alright. Anybody else have another way that they went about picking it? Alright.
Like, if you looked at the graph and then one was steeper than the other, like one looked like it had to fall off and then the other one was kind of like gradual.
Alright, so one of like the line was decreasing faster. It actually was. Okay. What does that mean? Like, what does it actually mean that it's the line on the graph is going faster? What's that showing?
It's showing a steeper slope.
But in relation to like the pennies and the radioactive decay half-life, right?
That's the amount of radioactive atoms that were no longer left.
So if you were said that something was faster, what's happening faster?
It's decaying at a faster rate. It's decreasing faster.
Yeah.
So more of them are leaving.
We're
You're losing.
we're losing more radioactive atoms
All right.
faster.
All right. So you're losing them faster. All right. So we have one last little thing for you guys to do with your group that you were with. And it's just a couple questions where you guys are going to be looking at a graph and you're going to have to get some data off of it.
Are they working in small groups?
You're still working in the same groups you were working in.
The group
For
of
your
3/4. All right, talk about it though. Talk about it with your group. Decide as a group. Collaborate.
Okay.
Make sure everybody knows what's going on.
That's an ugly five.
But it is still.
You know, think like this is an 8th grade class.
There's another squiggle right there.
And hopefully this will be a lot harder for 8th graders to figure out.
For half of the
The first sentence.
Well, it makes it go down.
Well, yeah, that's what I forgot to mention in my announcement. Like, I would have to okay, so let's talk about right here. Okay, and what it is.
These skills are not.
Your question helped a little bit. Oh, no, it's fine. Yes. Yeah, it's one. What's the half-life? So, like, what's every time, like,
No one's gonna read it.
All right. So if everybody will give me attention up here. Alright, so for this, you had to find out what the element is at 2.6. Can someone tell me what they got?
25%.
How'd you get that?
Because I went to 26 on, I went to 2.6 on the x-axis, and then I went up to the matching corresponding y.
Alright. Can someone tell me what they got for number 2? Someone different?
1.3 billion years.
Alright, and how'd you do it? Shoot the same way?
Yeah, I went up to the 50% on the y-axis, and then I went over and seen where the line corresponded, and it was on the one
Alright. And can someone tell me what the half-life is and how they found it on the graph?
It is half the time that, or it's the time that it takes for half of the element to